Hello students, today we're going to go and start on lesson number 10, which is found on page 213, and it's called Connecting Equations to Graphs. So now we're going to take all the stuff that we've learned about algebraic expressions and equations and that, and we're going to actually start now trying to see how we can link that to a graph so that you can kind of like look at equations and kind of see what the graph should look like. Alright, so they start you out with this first question, again on 213. It says Jada has $20 to spend on games and rides at a carnival. The games cost $1 a piece and the rides are $2 a piece. Which equation represents the relationship between the number of games, X, and the number of rides, Y, that Jada could do if she spends all of her money? Alright, so let's go over here real quick. And so this is what we got so far. We know that's $1 per game and times the number of games. That way the units will cancel. And then over here we have $2 per ride times the number of rides, and that all together is going to tell you the total dollar amount, which is $20. And as you notice, the games here kind of cancel for the units. So this just turns out to be 1x. All right, there's your variable right there. You don't know how many games she'll play, but you do know they're $1 a piece. And $2 a ride times the number of rides, I'm going to say that that's Y, so the number of rides is Y. And again, that ends up with 20, so you have essentially X plus 2Y equals 20. There's your base equation. So now if you look at this, right, which one does that look like? Well, it looks a lot like C. So that's your actual correct answer, is C. So what's wrong with these two? Well, first of all, this is telling me that it's $1 a piece for each ride or game. That's not right. Right? It's 1 and 2. And over here they're saying that the games cost $2 while the rides cost $1, which is backwards from what we're supposed to be doing. And this is actually the true equation. $1 per game plus $2 per ride times the number of rides that you have equals the $20. So C is the correct answer here. And I kind of just went through this, explained why each the other two could mean the situation. This means that the games and the rides cost exactly the same. This tells me that the games are twice as expensive as what the rides are. And so both of those are out. So the letter C was your answer here. All right. Now this next part's very important. So what are we doing here? It says there are 3 equations. Each represents the relationship between the number of games, X, and the number of rides, Y, and the dollar amount each student is spending on games at different parks. So here's equation 1, where you have games and rides totaling 20. Here's $2.5 per game, and this is $1 per ride, and you have $15 to spend. And this last one is $1 a game plus $4 per ride, and it gives you a total of $28. Right? So your teacher will assign you or ask you to choose 1 or 2 of the equation. For each assigned or chosen equation, answer the following question. What's the number of rides the students could get if they don't play any games? On the coordinate plane, mark the points that represent the situation and label them. What number of games the students could play if they don't get any rides? All right. So you're going to go to the extreme in each instance where you don't play any games, so it's all rides, and where they don't play any rides, don't get on any rides, so it's all games. Okay, so we're going to see what that looks like, and then we're going to actually go through and graph those. So let's look at these equations here. So you got X plus 2Y equals 20. You got 2.5X plus Y equals 15. And you've got X plus 4Y equals 28. So the question is, how do we get the points for this stuff? All right, so I'll show you a few tricks that we can use on this, okay? So here's your 3 equations. I'm just going to look at this like first one right up here, all right? So let's look at how we can manipulate one. Well, now when they're saying that there's someone plays no games and does all rides, or no games and rides, or vice versa. They just basically all or nothing. Okay, what they're saying is they want you to find out these two data points. All right, you have games over here and you have rides over here. Okay, so what we're trying to do is if there's no games, how many rides? If there's no rides, how many games? So let's just put those in here. If I put a 0 in here, then I have 2y equals 20. So in this one it turns out to be a 10. And if you take this same equation and you say, well, if I had put a 0 here, then x is going to equal 20. All right, so there's 2 points. Well, what are those going to look like? Well, 0, 10. All right, so here's your x's, here's your y's. In other words, here's your games, and over here's your rides, just to show you that. 0, 10 is 0 games and 10 rides. All right, so it's that little point right there. And this one is 20 games and 0 rides, so it's way out here. All right, there's your 20. Okay, and then you have those 2 points. Once you have 2 points, you can connect the dots. All right, so all you got to do is just draw a line between the two, and everything inside here tells you the combinations that you could do to get exactly $20 spent. That's what they're trying to get to you here. All right, so that's just one of them. All right, so you don't have, now you can go and try other combinations. If I said I wanted 2 here, or excuse me, five rides, 2 times 5 is 10, so x would be 10. So you got another point here. You got 10 comma 5, and that should work. If you put in 10 here and you put a 5 in here, that'd be 10 plus a 10, and that does equal 20. So if you over 10 and over 5, it's right on the line right there. Okay, so that one is 10 comma 5. All right, here is 20 comma 0, and this little point here is 0 comma 10. All right, and so all these little points lie on there. And so you could, if you try to put a number in that's down here or up above here, it won't match the equation, so it's not considered a solution. All right, so that's the easiest way to go about there. Select one to be 0, find out what the other one has to be, then select the other one to be a 0 and go backwards to find out what the first variable is. These are called intercepts. As you say, the intercept the y and intercept the x-axis. So that's a quick, easy way to do this. Right? We can go to do the same thing on number 2. So on number 2, we're going to do the same thing. We're going to do a 0 comma some number and then some number comma 0. Right? We're going to make it easy. Now let me go and switch over to a red pen now, so you can see it a little bit easier. So if I put a 0 in here, that means it's just y is left, so that's going to be a 15. All right, so it goes through 0 comma 15 this time. And if I put a 0 in here, that means 2.5 times some number equals 15. Well, if you take 2.5, or if you take 15 and you divide it by 2.5, it'll go in there 6 times. So here's a couple of points for you. So we can try to put it on the same thing. So 0 comma 15 is like way up here, 0 comma 15. And then 6, 0 is down here, like about right here, 6 comma 0. And now you have a graph that looks something like this. Okay, and anything on that line will satisfy that one. Okay, so that's the easy way to do that. Just get 2 points, you can just connect the dots. 2 points to find a line. So what is that going to look like? All right, well, let's go back, and this is the beginning in your book. So this is what it kind of looks like when you draw it up. All right. So that's what those things look like, okay? So here it is, x plus y equals 20. Now or in previous years, they've chosen to choose this last one. So this last equation that we had, this x plus 4y equals 28. So they did a 1-3 combination, and so they get this. And so, and we just like label them. And again, you see, what do? We put a 0 comma 7 in. If I do 0, 7, that's 0 plus 4 times 7. Well, that's 0 plus 28. All right. And then if you go out here, it's 28 comma 0. So I put a 28 here and a 0 here, and so 28 equals 28. All right, and we just did this x plus y one. We have 0, 20, and down here we have 20, 0. And you'll notice it's a nice, if you go through every little dot here, it'll cut through at exactly a 1-to-1 ratio. All right, this is called a slope. So we'll talk more about slopes later on, but just recognize what's the big difference here. Well, the difference is the slope. And why is there a slope difference? Well, it's because those coefficients that we find on x and y, all right, that changes your slope right there, those x and y. All right. So we kind of did all this. We drew a line to connect the two plots that you've drawn. Right. Complete the following sentences. If a student played no games, they can get on 20 and 7 rides. Okay. So that's the 7 and that's the 20. That's what they're talking about. For every additional game that the student plays, x, the possible number of rides, right? Number of rides decreases. In each instance, as you put on more games, you get less and less chances for rides. Same thing here. If you put on more and more games, the number of rides keeps going down. Okay? And this decreases by 1 divided by a quarter, or decreases like this right here. If you look at the rate of decrease, right, you'll notice that it kind of goes through this little point right here, goes through this little point right here, goes through this little point down here. And this is that slope I was telling you about. Here is your slope. Goes down 1 and over 5, or excuse me, over 4. All right? So your slope there, it goes down 1, right? So usually we talk about slope. We talk about rise divided by run. Well, the rise here was a -1, and the run was going in a +4 direction. So the slope is -1/4. Okay? If you look at this one, what's the slope? Well, it keeps going through these same little dots each time, so it's a 1-to-1 every time between any 2 points. So that slope is going to be down 1 to the right 1. So it'll be a -1 and a +1. So the slope there is going to be a -1. So that's the big difference here. All right? I'll put a little arrow here so you can see that's what's going on. All right? And it says, what's the slope of your graph? Where does the graph intersect? All right? So what's the slope of this graph? We already talked about that. We got a -1 slope and a -0.25, which is the same thing as saying -1/4. I prefer fractions myself. It makes it a little bit easier to understand. All right? And we'll put a little "and" inside here, because it's those two slopes. Okay, where does it intersect? Well, the intersections are like right here. Like, look at that. All right. All right. Where does it intersect the vertical axes? Well, it intersects the vertical axes. This. All right. This is the horizontal right here at 20 and 28. That's the horizontal. They want the vertical axes, so it intersects at 7 and 20. So we'll go and make that little correction there. All right, vertical axes. Rearrange the equations to solve for x. So we just take each one of these equations that we've had before, and we want to solve for y in this instance. All right. So you can go and take those same equations, you can solve them for y. X plus 2y equals 20. All right, so I'm going to go and move this over to his side. So I have 2y equals 20 minus x. And I'm going to divide everything by 2. So y equals 20 minus x divided by 2. All right. And so that's the nice thing about that one. This first one, x plus y equals 20. If I want to solve for y, I just put the x over on this side. I'm subtracting x. Y equals 20 minus x. So that first one, that's where you get. If you take this one, you want to solve for the y value. X plus 4y equals, let's see, what was it, 28? Right? Solving for y, so I put the x over here so I can get the y all by itself. And that's 28 minus x, divided by the coefficient of the unknown. 4, y equals 28 minus x divided by 4. So that's what your equation there. So they have a little bit different way of organizing it here. This is okay. I mean, we can go and I'll show you where that comes from. But essentially, we can take this equation. Remember, when you have addition, subtraction in the numerator, you can split the fractions. So that's the same thing as 28 divided by 4 minus x divided by 4. So if you look at that, what's this? 28 divided by 4. Well, that's just a simple 7. And then this, there's essentially like a little stealth one that sits right in front of that thing, like that. Right? You didn't change it. It's there. So that's the same as 1/4 times x. It's the same equation. All right. And so that's where they got this equation, if you want to write it that way. I'm not a big fan of decimals. I prefer fractions. What connections, if any, do you notice between the new equation and the graph? Well, if you look at this thing, the big thing to look at is this slope right here. What do you see right here? That's a -1 right there. That's essentially a -1. And then look at that. Right there. There's your slope. What do you notice about this? You got a -1/4. There it is. There's its slope. All right? So this little part right here leads us to this equation, y equals mx plus b. It actually, solving this thing for y, you can, if you find the slope, you can put that in there. And of course, this is called a y-intercept form, and if your x is 0, that means this whole thing goes away. So that value just turns out to be wherever the intersect is on the y-axis, thus the y-intercept form, because it tells you where it intercepts the y-axis. And it's nice because now you know why whenever we have equations, it's always y equaling something on the right. Well, this is the very start of that process. All right, y is all by itself. We solve for y up above, and we get this equation down below, y-intercept form. All right, and the second equation, right? So we start out with that second equation right there. We solve for y. Well, all you have to do is take that 2.5x and subtract it to get over to the other side, and you get this. So if you look at this, there's your slope again. The slope is -2.5, and it goes through at, if your x is 0, it'll go through 15. So 0, 15 is where it stands, and that's its graph. 0, 15 is where it intercepts the y, and there's the slope. It goes down 2.5 for every one drop, right? So if you go over 1, this drops down 2.5, so it goes from 15 down to 12, right? So it's kind of nice. Okay, if you go down 2, right here, it's now dropped 15. Excuse me, it's dropped 5 from 15 down to 10, so it's dropped 5. Again, you've gone down and over. All right, so that's a -2.5 divided by a +1. So you get a -2.5 for your slope. Okay, and we'll continue on here. Draw a line to connect the 2 points you've drawn. Yep, we got the 2 points. We have 6, 0, and we have 0, 15. You can put those numbers end up here, and you will get these coordinates. Right? Okay, complete the sentence. If the student played a game, they can get on 15 rides, 15 total rides. That's the maximum they can ever get. That's how you read these graphs. For every additional game that a student plays, the possible number of rides decreases, right? Because as you go more rides, the number of games, as you increase the number of games, you get fewer and fewer rides. And it decreases by 2.5, 2.5. Thus, decrease because it's negative, right? It decreases because it's a negative, and it's 2.5 because if you go over 1, you drop 2.5. Okay, we continue on. What's the slope of the graph? Well, we just kind of answer that. It's -2.5. We see it in the graph, and we also see it in the equation. Rearrange the equation, solve for y. Okay, we kind of did that up above. Alright, so that's that same solving it for the y-axis. What connections, if any, do you notice between the new equation and the graph? Well, slope is negative 2.5, and the y-intercept happens at 0, comma 15. So that's the big things to take away from that. So that's what all these graphs, all this algebra has been meaning so far, leading up to this point. Same idea now. How we have it nickels and dimes, okay? Nickels and dimes. Well, let me go and get a new fresh paper here for us. Okay, nickels and dimes. Andre's coin jar contains 85 cents. There's no dimes or pennies in the jar, so the jar is all nickels, dimes, and quarters. So, excuse me, there are no quarters or pennies in the jar, so it has only nickels, has all nickels, all dimes, or some of each, some combination. All right. So write an equation that relates all these. Well, let's start there. If it's all nickels and dimes, I know that a nickel is 0.05. And I'll put a little in there for the number of nickels. And I add the amount of dimes, which is that much, right? So there's 5 cents, right? 10 cents, and we can show that as D, and that can be 0.85. So that's 85 cents, 10 cents, 5 cents, number of nickels, number of dimes. An equivalent would be, if you just put everything, so this was in dollars. What if we put things in cents? Well, 5 cents times the number of nickels plus 10 cents for every dime equals 85 cents. Now you'll notice the difference here. All right, how do you go from dollars to cents? Well, there's a factor of 100 involved there, obviously. All right, so what's the factors here? Well, if you take this number, multiply by 100, boom, you get that. You multiply that by 100, you get that. You multiply this by 100, you get that. These are equivalent fractions or equivalent equations for you. Okay. So if we go through that, this is write an equation. So here it's all in dollars. You can have it in either dollars or cents. It's the same difference. Okay. Graph your equation on the coordinate. Make sure to label the axis. Okay, so we got to figure out this little point right here, and we got to figure out this little point way down here. Okay. What's the easiest way to do that? Well, do the old intercept trick. 0 comma some number, comma 0. So if I make this 0, all right, can I make this 0? Well, if I make this 0, I can't really make 85 cents out of 10 cents. I mean, I could say a half of one, right? 8.5 times 10 is 85. No such thing as a half a dime, so that's not really a combination that I could think of or I could see happening. But that's a good point on your graph. That is a good point on your graph. And these are just points, right? These are potential solutions. Let's go back the other way. Let's make this 0 dimes. So how many nickels do you need for 85 cents? Well, let's think about this. How many nickels do we need for $1? Okay, think about it. How many nickels are in $1? So 2 nickels is a dime. So if I have 10 cents, a dime, all right, that was 2 nickels, right? And then 10, 20, 30, 40, 50, and you keep going up, and you're going to find out that you need 20 nickels equals $1. All right? You can do the math in your head if you'd like. And so if you think about this, I don't have $1 though. I have 85 cents. So if you want to go $1 down to 85, that means you had to get rid of how many nickels? Well, that's 15 cents, so that's 3 nickels. So 20 minus 3, 17 nickels. So 17 nickels and no dimes will give me 85 cents. All right, so here's your 2 points. All right, so let's go ahead and actually put this on. So what's this little point here? Well, let me move my face out of the way here. This little point right here is that 0, 8.5. So 0, 8.5. And what's this little point down here? Well, that's your 17, 0. So 17, but you don't go up any, right? 17, 0. there's your points. Once you got 2 points, draw a straight line. And then these give you the possible solutions. Now obviously we can't have like fractions of nickels and fractions of dimes, so there's certain integers that we'll have to go through on this one. And if you're going to have 85, that means you have to have at least 1 nickel, right? If you have 1 nickel, that's 5 cents, which means that you'll have to have 8 dimes. Can I have 2 nickels? Well, if I have 2 nickels, it's just 10 cents, right? If I have 10 cents, then there's no way for me to get that extra 5 cents out of that. So I'd have to go to 3. 3 times 5 is 15. Now I'm down to 7 dimes. And what you'll figure out here, if you keep going on this logic, n has to be an odd number. We have to have an odd number of nickels. I can have 1, 3, 5, 7, 9, 11, 13, 15, all the way up to 17. All right, so there are these little dots on here actually represent those discrete increments, right? You have to have an odd number of nickels. So I have to have a 1, a 3, a 5, a 7, 9, 11, 13, 15, or 17. And that corresponds, if you go up, all these little dots here correspond to your dimes on the other side, right? How many dimes are in the jar if there's no nickels? Okay, if there's no nickels, that's 8.5. 8.5 dimes. Even though this is not possible, we have 0.5 of a nickel. Half of a nickel. So, ready for more? And so you can find different ways if you have 85 cents to have a certain quarters. And there's any number of combinations that you have on here. So you can look at those and expand upon that if you want. Alright? And so, the summary. What did we learn? Well, it says linear relationships. Oops, let me go move this just a hair. There, that should focus a little easier. Linear relationships can be written in different forms. Some forms allow us to better see the relationship between quantities to predict the graph of the equation. Suppose an athlete wishes to burn 700 calories per day. There's your 700. By running and swimming, he burns 17.5 calories per minute of running. So there's it. There's your running right there. Right. And 12.5 calories per minute for swimming. Okay, so over here is swim. Let x be equal to the number of minutes running, y is the number of minutes swimming. To represent the combination, you would have this equation right here. Alright? And we're going to do the same thing. We're going to substitute in x, 0 for x. Alright? And we're going to see what happens. And then we're going to put in 0 for y and see what happens. Alright? And so they got this a little bit messed up in your book. Let's substitute 0 for y to find x. Let's substitute 0 for x to find y. Okay, so make sure that you read that kind of carefully because it's a little bit confusing. They're going to try to find x and find y. Well, if you do this one, they're going to have 0 for y, so that's that one. So that's 40 comma y. And 0 for x right there. So you're going to get 0 comma 56. So there's your 2 points. You can start drawing a line. All right. And then they took this same equation. What did they do? They want to solve for a y. Oh, okay. So let's see how they did that. So they took this equation. They moved the 17.5x over here by subtracting it. So you get a minus 17.x. And you just want one y, not 12.5 of them. So you divide by 12.5. And that turns out there. And then they split that. This is what they're saying. They're saying 700 divided by 12.5 minus 17.5 divided by 12.5x. Okay? And so there it is. There's your equation right there. And this is very close to y equals mx plus b. I'm going to rewrite this in this form. I'll have the y equals negative 1.4x plus 56. So what's this telling me? There's my slope. It's in negative 1.4. And this is telling me that if x is 0, if that's 0, then the y turns out to be 56, which is also the y-intercept. Very handy. Okay? So just keep that in mind, what you see there. All right, and then they go on and they start showing you the graph. Okay, so there's your 0, 56, there's your 40, 0, there's your y-intercept right there. This, by the way, is called the x-intercept. And if you notice what the slope is, if you do the math, the slope equals a negative 1.4. Right? Negative meaning it's going down when you go left to right. Okay? And so that's really what's going on there. All right? That's all there is for lesson 10. Next up is going to be your lesson 10 practice problem. So again, try the practice problems first and then watch the video. All right? And that's all I have. Thank you.